In this example, we have to minimize this Boolean expression. We can note that there's one NOT gate on top of all the terms, which probably suggests the use of the De Morgan's law. While the De Morgan's law is important for this question, I suggest that we do not always immediately start with the De Morgan. First, we can look at what there is written underneath the large NOT gate and check whether we can do some minimization there. In this case, a quick look at these two terms will suggest that we can take out B0 and C0 as common terms and try to minimize what is written under the NOT gate first. So I'm going to leave the C0 and D0 as they are, but here I'm going to take out the B0 and C0 as common terms into A0 or A. And obviously we'll have to leave the NOT there. Here we have used distributive. If we have a look at this bracket, using tautology, we can get rid of it and it will be converted to 1. Using tautology. And using tautology again, we can get rid of that 1 and obtain C0 and D0 or B0, C0, not. Now it's time to use De Morgan, and we can split that NOT gate and change the sign. So C0, D0, not, and B0, C0, not. Remember that here we have brackets. I am going to apply another De Morgan on these to get rid of that NOT gate. And then using the double complement law, we can get rid of those knots because they cancel each other. Now, if you compare this to the distributive law, to this one, C or D can be mapped to A or B, and B or C can be mapped to A or C. Obviously, in this case, instead of A, we have C, instead of B, we have D, and instead of C, here we have B. So this, since we have C, which is common in the two terms, we can write it down using distributive as C or B and D. And like that, we have obtained the minimized version of this much more complex Boolean expression.